Okay, today we're looking at momentum, and momentum is I like to define it as inertia in motion. If inertia is being a measure of mass, motion we're looking at velocity. So the symbol for momentum is this small p, and that's equal to mass times velocity. The p symbol comes from the word impetus back in the olden days, which basically means that the energy the energy with which an object moves. The units for momentum come straight from the formula. Mass is measured in kilograms and velocity is measured in meters per second. So its units are kilogram meter per second. Different objects can have the same momentum as long as the products of the mass and velocity are equal. So an impulse is what we're defining as causes a change in momentum. So impulse is defined as force times time, which is equal to the change, remember delta means change, in momentum. Or we can write that as P final minus little p initial. This basically is derived from Newton's second law, where F is equal to ma, and we know that the acceleration is equal to the v final minus v initial, all divided by time. If we then take and multiply through by time, we have Ft is equal to mass times v final minus v initial, that's a minus, and there is your impulse. This is defined as impulse. There is your change in momentum. So impulse equals change in momentum. Notice that we can have units of mass being in kilograms and velocity being in meters per second, or we can have it in terms of a Newton and a second. So either unit is acceptable. So impulse usually found in newtons per second, change in momentum kilogram meters per second, but really are both the same units. So in summary, we have that momentum, P is equal to mass times velocity. The change in momentum then is equal to mass times the final velocity minus the initial velocity. And we have impulse equaling force times time, and that can also be found as mass times that change in velocity. Momentum units are kilograms meters per second, and impulse is usually in units of newtons times seconds, but recognize that both of those two units are equal. So let's take a look at an example. Okay, example. So we have, how fast must a 0.5 kilogram snowball be thrown to have the same momentum as a 4 kilogram wagon traveling at 5 meters per second? So if we pull out what we know, we have m1 being 0.5 kilograms. It has the same momentum as a second mass of 4 kilograms traveling at a speed of 5 meters per second. So we want to find how fast. So the momentum of 1 must equal the momentum of object 2. So m1v1 must equal m2v2. So m1 is 0.5 kilograms times v1 we don't know, must equal m2 being 4 kilograms times v2 of 5 meters per second. So if we solve for v1, we have v1 then equaling 4 times 5, which is 20 kilogram meters per second, all divided by 0.5 kilograms, which comes out to 40 meters per second because the kilograms cancel out. Okay, let's take a look at another example. So here we have a 0.5 kilogram ball traveling at 10 meters per second east, collides with the wall and bounces back at 9 meters per second west. Part A, looking for the impulse of the ball against the wall. And part B, if the ball was in contact for a time of 0.5 seconds, we're looking for the force that it applied to the wall. So here we have a mass of 0.5 kilograms, it has an initial speed of 10 meters per second east and a final speed of 9 meters per second west. We're looking for the impulse, which is force times time, or mass times change in velocity. So since we have the mass times change in velocity, so we have impulse is equal to m times v final minus v initial, which is 0.5 kilograms times v final of 9. It's going west, so I'm going to make that negative, minus the 10 meters per second, which is that's a minus 19 times 0.5, which makes that a minus 9.5 Newton seconds. So there's part A. For part B, we'll look for if the ball was in contact with the wall for 0.1 seconds. We're looking for the force. So here, time now is 0.10 seconds. We want to know the force. I'm going to let you see if you can come up with a force and see what you get.